So hello, I'm Mace Ringer and I am trying to make the contact process work. So I have been making ammonium metavanillate or whatever, and now I'm going to, and I have already precipitated out to some alumina chunks that I broke from a Dremel bit. Here is the chamber, which you can see here is two electrodes going into the, basically to the, I don't know if it's, yeah, it is visible. There is a little cup that has, or that is going to have sulfur inside, so sulfur dust. I am pumping oxygen, or at least air and oxygen, through one lead, this one. So yes, this lead is going in, as you can see there. That is the intake. This is the outtake, this one. This is going to go to the catalyst, which I showed you. There, inside there is an overpressure, which pushes the air and sulfur dioxide out to the catalyst bed, and the catalyst in theory reacts with it on paper and on reality also, but I'm not sure if I have the right shit, so I am going to test it out. If nothing is happening or I'm not successful, I will go back to the planning board and try to do something differently. So yes, which I want to show you is that these electrodes have been added to the chamber, which help to keep up the temperature, because I have had some struggles in the past too. So when I lit the sulfur to fire, after a while it extinguished itself because it cooled down enough, so it did not burn anymore. So for this reason, I have here a 5000 volts transformer that can generate an arc between these two electrodes, and these two electrodes will light the burning sulfur, or at least will heat it up sufficiently enough so it will keep burning. So I don't need to like get in there, get the little pot or little cup out with this shitty snipper or something, and whilst I'm like getting a lot of sulfur into the atmosphere and also to this work environment, which I would not like to do. So after that, the sulfur has burned, it comes through, as I said, to the catalyst bed, then reacts with the vanadium, forms sulfur dioxide, then goes into a, here is a very shitty but working bedded, a simple absorption tower. So this is basically the catalyst here, and then the catalyst goes inside, goes around, goes around, goes inside there. It goes through a lead, and it goes to here, and this inside, as that you can see here, is safety glass. So it is like a tempered glass that has been shattered into little fine pieces. I've collected it up. Also there is some dirt and debris on there, so it is not perfectly clean because I didn't have the, like, I couldn't be bothered to fucking clean it. As the bubbles come through this lead, they go in a random like order, and between these little shards of glass they have a, like a higher, how do you say this, like a bigger path that they have to make than if they were to just go straight up and out from the bottle. So between these little glasses, on the glass surface they actually slow down because they can't go as fast as if they were going through like pure water. So once they slow down, and on the other hand they have to make a longer path, there is like a pressure drop inside the absorption tower. So after the absorption tower has gathered as much as possible, this lead goes outside, and as you can see there are like shitty mason jars all over the place. This is a broken one, so not this, but like that one that has like calcium hydroxide and water combination. So that is the calcium hydroxide. It is not really soluble in water, so this is why you see the white gunk on the bottom. So yes, I'm going to hook this up, so the remaining sulfur dioxide or trioxide or whatever bullshit that remains is going to go and just get dissolved and neutralized by the basic solution of calcium hydroxide. So I have hooked it together, and here's some unburnt I don't know if it is visible, probably not. Unburnt sulfur from the previous one. As you can see, this was at least stainless steel. From the outside it can be visible, but from the outside or in the inside even, the sulfur has just completely corroded this shit. I'm going to put some more. It looks a lot, but it generally isn't, because it tends to like form a liquid, then it is going to be denser, because this is like a fluffed up version of it. A lot of air is inside. Fuck. So here it is, the pump is going. The water is going up, as I said, going through the little pores all over the place, and going to get here as the pressure builds up, or if my whole system is not leaking. I hope so. So I'm going to I guess I can't really. I'm going to turn this off. Oh, this works. Oh, let's go. We are getting a good smoke. Put this on, so I'm going to. So yes, we are definitely getting some sulfur dioxide. Turn this off. Oh, fuck me. Captain, we have a problem. The system is leaking. We have to fucking. But. Wait a minute. Like, it is really misty. And. It is producing, I think, a ton of heat. Yes, I mean, locally, definitely, because, like, as you can see, this is like still real very cloudy, but I think it is clearing up, so I'm going to just burn it a bit more. It's going to. You can see here, you can see there the arc. So I'm back with some proper safety equipment. As you can see here, still is leaking, and here the mist is coming out. So I probably will need to change this to something more drastic. Yeah, I guess Mr. Sodium hydroxide is not able to solve the problems either. Yes, I have to use more of a higher column to react. Maybe the system is not working properly, because I don't think the temperature is the problem. I think the problem is that they are not sufficiently covered with the bedding material. This, oh, did you see that? So the bedding material is the problem. I will have to come back and do some more vanadium chemistry put some more vanadium onto these goddamn stones, and hopefully that will be good enough.